So the first thing I want to do is I want to throw up some text, and I want you to, while this text is up, I want you to count the number of each word in this text and tell me what the most common word is in this text. Okay? So here we go.
My name is Tyler Devereaux. I'm inviting you to attend my brand new 2-hour live masterclass, and I'm about to show you what 99% of real estate investors don't understand. Me and my students land and profit from these big deals all the time from what I'm about to teach you. These are big, sexy apartment deals that nobody ever talks about, and they are in fact much less work.
Okay, so I kind of made that hard on you on purpose by moving around and distracting you and confusing you. But even if it's not moving at all, it's a little bit, tricky to do. You probably stare at it a couple of times. Your brain is going back and forth and back and forth. And so text analysis is one of the great things that computers are very, very good at. And some of the things that, they can translate text, and that's because they've looked at a lot of information. So looking at text is actually something computers are really good at. And so if we take a look at the kind of programs that we're going to write to do this kind of thing, this is something that humans are not naturally good at, but computers are super good at. Now, I'm not going to have you look at this code. This code you'll understand in a few weeks. But basically, this is a set of instructions to open a file, read that file, read all the words in the file, create a histogram of all the words in the file, and then search through that histogram to find the most common word and tell us what the most common word is in the file. And in this clown file, the word the is the most common. It happens 7 times. And here's another large file called words.txt, and the word to is the most common thing. And our goal is to get to the point where you can write this on your own. So you can say, you know what, I got a problem to solve. That is, what's the most common word in this file? I know how to start, and then I know how to finish. I know how to do the stuff in the middle. And we have to learn this kind of weird language. But when we do, we can count millions of words as easily as we count 20 words. So that's the fun of all of this, is to teach you this language so that you can solve that problem so that you don't have to solve it. Because you could solve it, but it's not something that you're naturally good at, and it's hard work. So up next, we're going to talk a little bit about the hardware architecture that you're going to be experiencing as you write programs. Hello and welcome back to hardware architecture. Now you might ask, why do I tell you about hardware architecture? Probably you're not going to build any hardware, although it's fun stuff to do. And if you're going to become a computer scientist, which most of you won't want to be, it's a great thing to study. And those who build our hardware are amazingly talented individuals, and it's a really rewarding job. The reason I like talking to you about hardware is because I want to be able to use words at some point and say, oh, secondary storage, or central processing unit, or random access memory, or peripherals, input devices. And I want to be able to say those words, and I want you to be able to understand them. And so I'll start with a little piece of hardware called the Raspberry Pi. And the Raspberry Pi is a cute little single board computer. As we go forward, these things are smaller and smaller and smaller. And the interesting thing is that the architecture of these stays the same, but the number of components drops. So I'm going to start and give you a block diagram of sort of a generic computer and tell you the major parts of it. Now, I'm going to show you some really old hardware, some really new hardware, and then some hardware that is of medium age. And the medium age hardware is probably the easiest one to see. The architecture is the same, okay? And so the basic block diagram is that the brains, if there are brains in computers, which there really aren't, the software is the closest thing computers have to brains, but in hardware, the closest brain a computer has is this, called a microprocessing unit or a central processor unit. And this is designed, 3 billion times a second to ask the question, what do you want me to do next? And these little pins on the back are our instructions, like 32 or 64 of these pins. 3 billion times a second, we send an instruction into these things. Now, we can't sit there and talk to it. We can't. And so the instructions we store in what's called the main memory. And this memory is really fast. And the memory sort of feeds this. And so every time the CPU needs a new instruction, it asks the memory where that instruction is. And so the memory feeds the instruction, the CPU does it, says give me another instruction, CPU does it, gives you another instruction. And that is the basic essence of programming. This asks what's next. And this is where your program is stored, or a program you purchase